It's a good thing you said that, because I totally wouldn't have been here. Yeah. Have you guys been here?
Not for long.
It's like a 50-50 if I figured out that it wasn't.
Actually, they say they do it because of lab classes. But I teach several lab classes, and it always screws up our lab schedule. But their idea being that we get the same number of Mondays, Tuesdays, Wednesdays, Thursdays, and Fridays every term. So regardless of which day you have lab. But when it starts on Thursday, and it's a Monday schedule, and labs are scheduled to happen before the first lecture, it's unlikely that you're actually going to have lab that day. So I get the rationale behind the system, but I don't think they get the solution correctly. Here's up to you guys. Look at this. Yeah, so I was going to have a robot for the lecture. Today's should have stayed in my office. It does like a live webinar for today's lecture. Talk about automation. It could have been an automated live webinar. I could have been pretending that it was live, like a computer program. Internet automation.
So then you would have to rely on your student workloads to make comments, and you make it look like you're doing
a I've attended several of those automated live webinars, and they don't try that hard to hide the fact that it's automated. So I think we are ready to go. 1, 2, 10 people. That's better than the Monday that you get, right? Yeah.
Or your car is stuck in Maine in the mud, and you have to rely on the tractor to pull it out.
I totally think it is right.
You try to drive through the storm.
All right, so factory automation systems. Why?
Why would we use robots to replace someone's task? You agree it's either because it's...
So if we're a company and we have a process, and it's an established process, and we have a weekly throughput of parts. So we get a company, we get an established process, we get repeatability. So we want to improve our repeat ability. Why else might we want to automate? Why else might we want to automate our process?
It's cheaper.
So we want to make repeatability go up, make cost go down. So we make repeatability go up, cost go down. Anything else?
Increased safety, less operator intervention.
So why do we want to improve safety? Safety to go up. Right, bad safety costs, right? So there may be other intrinsic reasons that we want to improve safety, like we're not jerks, right? And we want to continue to be not jerks. Yeah, I pulled that. That wasn't the word that came to mind. But so we may want to, in general, be safer, but from a business perspective, poor safety record has high costs. It makes our insurance premiums go up. It makes our lawsuit costs go up. We've got to hire more lawyers. Just bad safety is a bad plan for any company. So when you see companies that have bad safety track records and that are not promoting good safe practices, those people are bad at math and jerks. All right, so what else? What else might we want to, why might we want to automate our process? Remember, this is an existing process. We've got customers, we've got orders, we know that the orders are going to continue to come in.
So the accuracy of your parts.
So improve repeatability, improve quality. So you can simply automate the inspection process and improve quality. We did a project several years ago with it was with a company that manufactures golf clubs. And they manufactured $600 golf clubs. And until I did that project, I did not know that you could pay $600 for a golf club. But I guess you could pay whatever you want for whatever you want, if that's what you want to pay. But so what gets a $600 golf club from the shelf to the cash register? Right. So, all right, so first thing is like brand name, right? Brand recognition. The customer believes that this is going to make me not hook it into the woods. That's a hook, right? Right, golf people. So it's like a slice and a hook, right? So if I'm doing this,
So you're ready.
that's a slice, that's a hook. Okay. I'm going to hook it. I figured out, so I really like golf. Golf's a lot of fun. I figured out that I play golf on average once every other year. And that's if I add up all my years and the total number of golf games I played. But so brand gets it from the shelf to the cash register. But the other thing is it's got to look good, right? If I'm paying $600 for a golf club, it can't look like crap. So I'm going to look at it and I'm going to think, oh, look at the finish on that. This one is beautiful. We'll bring it over. We're going to buy this one. Here's my gold card. Here's my platinum card. Let's get this golf club. Let's get it. Improve my game. So that's great. This golf club manufacturer had a guy named Joe, and he was at the end of the production line, and his job every day, all day long, was to go, that's a good one. That's a good one. That needs rework. That one's scrap. Joe's job was to look at the finish on the golf clubs and decide which ones went to the store. And maybe he would send the ones over here to go to a different store, right? He could sort them. And so the company actually had a serious problem because they start tracking the data, right? You put them in spreadsheets, you do analysis, you look at the signal, what's going on, and they found a strong correlation with Joe's rejection rates. They noted that the day after the Red Sox lost, failure rates skyrocketed. Joe had some bias, right? So they wanted to replace Joe with an automated inspection system that could do the things Joe did. So we can improve quality simply by making our measurement better, by automating our measurement. All right. So we want to improve our repeatability. We want to reduce our costs. We want to improve our safety, improve our quality. Why else might we want to automate a process? So the task might be tedious. The problem with a tedious task is people stop caring about it. I think it makes quality go down. So I think the real problem with a tedious task is it's hard to hire a high quality person to do it. And if you don't have a high quality person, you're going to get a low quality throughput. So I think that's the big problem with the tedious tasks. So I think we've covered that with quality. Is there anything that we're missing here? Why we might want to automate?
Speed.
So we may have more orders than we can fill. So we may want to improve throughput. So repeatability, cost, and repeatability really goes to quality, doesn't it? Well, it goes to quality and cost, right? Because the first step of quality is not ship crap to the customers. We can catch that at the loading dock and just not put the crap on the trucks. Or we can catch it in the process and not make the crap, right? And so if we get a more repeatable process, we may make costs go down, we may make quality go up. Is there anything else? Is there anything we're missing here? If we're a manufacturing company and we want to automate, and we're considering whether or not, so this is at the stage where we're considering whether or not we should even go out for a quote to improve our process. Does it look like we've covered everything? But I think we got most of it here, right? What's the driving factor? What's going to make us make our decision, whether a go no go decision on the project? It's probably going to be cost, right? I guess what we're truly interested in is profit. If we can make profit go up, in fact, if we can make profit over time go up, then we win, right? If we increase the profit rate of the company, then the company is going to continue to grow. It's going to continue to employ us as engineers. Who plans to be an engineer when they grow up? Everyone should raise their hand. She's going to be an engineer. She's right up. She wants to take stuff apart just to see what's inside. The engineering training there. All right, so we want to make our profit rate go up. And cost is probably going to be the primary. So if quality goes up, so profit is value minus cost over, right? Profit is value minus cost. So we could drive the value. We could make the quality go way up so that we can start charging more for it. And we could drive our profit that way. But typically when we look at improving our profit for an existing process, what we're doing is reducing costs. So what goes into, all right, 4 groups. I'm trying to decide if I want to ask this question before or after the group part. 4 groups, how many people we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 people. That's 3 groups of 3 plus a person. The extra person can take a spot. All right. I've got a case study that I want you guys to look at with your group here. This looks like a group of 2.
2 twos.
All right, we'll do 2 twos. You guys like ballet, I guess. All right, so in our case study here, what we've got is a system where there's a company, they're making 20,000 parts a week, right? 20,000 pieces per week. It's a forging. It's part of a jet aircraft engine. And they've got a manual process where they are currently making that part. So here's a description of the part. There's a picture of the part that they've got there. And what they want to do is see, can we replace the manual process with an automation system that will do the same part. And so there's 6 steps in the process, your thing probably isn't as bright as mine. But you're gonna look through the 6 steps in the process. All right, so each group should do a quick scan through the 6 steps. This works better when I have 2 groups, the math works better. You guys look in detail at steps 1 and 2 to see what do you have to know, what kind of sensors would you have to include in your automation system, and what kind of actions would your automation system have to do in order to automate steps 1 and 2. The 2 groups of 2 look at steps 3 and 4 in detail. So look at all 6. Each group should read through all 6 steps quickly. But look at steps 3 and 4, and then you guys do 5 and 6. And so what do we have to know? Do we have to know when the oven door opens, or furnace, when the furnace door opens, when the furnace door closes? Do we have to know, so which sensors, what things do you need to include in your process? And feel free to sketch out sort of a flow chart or a schematic of how you would attack those steps as you go through this. So again, we're making 20,000 pieces per week. It's a manual operation, it runs 5 days a week, Saturday overtime is sometimes required. And so this is a significant process for the company. They're making a lot of these parts. They're basically, the orders exceed their capacity because they have to work overtime sometimes in order to fill the orders. So they're at the edge of their capacity in general. So I want you to look in detail at the things that you need to know and understand in order to get from one step to the next, and do a quick flow chart of the steps that you go through that process. So you use maybe use a sensor to detect when a part has arrived at the station, that then turns something on or turns something off. So the step through the steps, and I don't know how to actually make a flow chart with all the correct symbols, so I don't expect you guys to know how to actually make a flow chart with all the correct symbols. So just like indicate what you mean, draw a little flow diagram of what you expect to go on. It will we'll do this for 15 minutes until the big hand gets to the 6 on the clock. All right, so you got 15 minutes to go through the steps that you're tasked with. Look at what are the sensors, what are the things that you're going to have to do in order to make that happen, and draw the little flow diagram.
Oh, we could choose that. Oh, okay. Sure.
Need to be a little bit interactive. What you should do, because you're logged in with my account here when you do the thing. So if after the video gets in here, if you go into YouTube and add it to the playlist, and the playlist for those classes lectures, and we'll all do the ones that, so it's up to, not all of them are in the playlist right now, because I forgot that we have to do manual operation there.
Yeah.
So we'll just go back there here, I'll put it on the playlist.
Okay.
Yeah.
Oh, what do you? Is this the old one? This is what was in the old.
I had just put that in to start charging you guys.
Yeah, but is there any difference in images?
It should be a little on battery, we can charge it.
It just goes into the auto turn off mode. Oh, I didn't know that.
You guys need this paper to write on? Just making sure. I'm not 100% certain everybody is intending to take notes when they come to class. Yeah. So I don't know. Yeah, like do they? So they have.
Actually.
You're assuming it's actually using the second filter for. Alright, well then.
No, I just. Yeah, I just, so. Yeah, so I don't know. So coming from someplace that may or may not see the next well, and so they're in the camera. Yeah, it's just, well, yeah, earlier, drivers can do the camera. Yeah, so we could really need like to they should be putting software. A lot of software. You could have like an outside press block all of the different guys on the same. It's probably something. Yeah. The issue, the shape of that. So that's where we did. But I assume you can have all 6 of those lined out. Yeah, small.
Yeah, it's what's a term.
How do you work on it?
Oh, that.
Oh, you're at the three, that's the one you. Oh, the market. Oh, I would say. But yeah, no, that's a little. So there would go out on the there. That's it, see where and or. That's why we use. Yeah, this is one. So I don't know. I want to actually. Image one is full. So I guess then, say, going back where there's, supposed to be a cut, and then it's where it is. So this is. So probably need to spread. So we need to orient this. So the coming from the board, they need to be oriented in a way that all the bad ends go off the zone. The next step. Yeah. So you can align it. Align, spray. I would say you use a line first. I don't think that's as important. Yeah, the next step is probably. As soon as you there's a visual inspection. I think as long as it's going the right way, you don't want everybody to keep it back. And you'll have to make some assumptions. Yeah. And then now you want that longer to the other group. So we need to study regardless of what is what. So we actually spring. So there's nothing auto operations can be one straight and then it's so the other thing you might do is, especially if you do is they'll have sort of chain brackets. So you'll hang it on a fixture side of the harness. And then you grind it on the so you may have a way to insert. So yeah, you can and that's probably already this is my process. So they've got some manual way that you operate. So it takes 3 seconds. So you could just that part of it, you can assume that you're interfacing block or 3 sets of giant toms. You have 5 setters take it out with giant toms and make on next hour. So you can assume that whatever end effector the operator is using, or however you want to get it out of 5 to 6. So it could be a fixed automation system. It could be so this level, we're looking at the very high level hierarchy of what do we have to be, what steps do we have to be in the arm, how do we have to know about those steps. So we don't need to get into detail of I'm going to buy ABB XYZ robot that does this and that, or it's a very high level. There's a pick and place operation. Yes. There's a robot for that, or a sensor.
Very high level. This is sort of, we can assume that we're the company here, and we're sort of deciding what tasks we want to now go hire some engineers to figure out how to do one. So this is management level decision. We're all working on manager happy today, or manager false positive. Yeah, but I assume they're gonna be. I assume that if it's line is like 5, you're not going to go again. All right, another minute or so, then we'll gather back together. And then the same rivers that are like All right, you guys did step 1? No. You guys had 1 and 2. Sure. There was no 2 and 3 group. It was 3 and 4 group. All right. So what do you need to do in order to be able to perform steps 1 and 2? But feel free to stand up. We'll talk to class. You can if you want to. Bring your flowchart up. Talk to class. All right. So steps 1 and 2. What do we have to do to complete steps 1 and 2?
We have to find imperfections in the stock.
You're looking for imperfections in the stock.
And cut them.
Okay. And so in cutting the stock involves forming a stock, right? And so the procedure is you get a bar of stock material coming in from the truck full of bars of stock material. And it's going through some system where we have an ultrasonic scanner that's looking for good and bad stuff. And when the ultrasonic scanner gets to the part where it says, this is bad stuff, the operator takes out a Sharpie, marks the part. He says, it's good stuff again. He marks the part again. And so we know that we don't include that bit that's been marked off in our system. So how did you guys want to automate that part of it?
So we had a sensor that was noting the beginning of the rod feeding through the ultrasonic sensor, so it can track the location.
All right, so you're monitoring the position of the velocity of the bar as it goes through a sensor. Yeah. So you're pushing it through a sensor.
Then they know the next location where that spot started and where it ended.
Okay.
And then it sends that down there to.
So that comes down here to the controls for the shear.
Yep.
Okay.
And then bar loaded into the shear, and it was heated in the shear, and then it was also, we had another sensor in the shear that took out at the start of the bar, keeping track of the X location. So the ultrasonic data, we cut into that and say, at this X location, do a cut, and then when it's bad, do a cut again. So you just cut out all.
All right, so you're pushing the bar into something.
Yeah.
You know the velocity at which you're pushing it.
Yep.
So therefore, you can know the X and Y locations along the bar as long as you trigger an event of good, bad. Yep. And then you can also trigger a start stop for the push when you get it to the position where the heater and the shear is, right? So it comes through this, what's the word? The induction heater. Goes through the induction heating coil, goes in there, it advances to the shear, chops it off. And so if it's good material, what do we do?
We had
The bottom is good materials cut, and the top is bad materials cut. So 32.2-inch section, so the machine would know or whatever.
Yeah.
You would know how long it has to move to make a cut, say in a half-inch material, and then you do a half-inch cut, and then sort it into.
So you're pushing, sensing, heating, cutting, pushing and sensing, heating and cutting as you get to those spots. And then you're converting good material one direction, bad material another direction. So you got some sort of gate that the good and the bad material sort out. All right, so is that step one, or is that step 1 and 2? That's step 1 and 2. All right, yeah. Does that make sense to you guys? Roughly how you guys would do it? All right, groups that had steps 3 and 4, come on up. Tell us what you're going to do, how you're going to automate steps 3 and 4. And you guys can arm wrestle if you disagree on the method.
We only have time to go through step 3.
Oh, we do.
Okay. When,
That's all right.
so first when the machine heats the part, there's a sensor that turns on the heat process. And then the part is sprayed till the thickness of the lubricant is what we want, and then the spray stops. And then a robotic arm removes the part and places it into the tray, one after the other. So there are already 3 different ovens. So we're going to use the 3 different ovens.
Use the existing 3 ovens, use a pick and place robot to move it to where it needs to be to get into that spot. Okay?
And then a sensor detects when the tray is loaded, and an automated belt will deliver it to the oven. And then when the oven sees that the tray inside, it closes the door automatically. And then when the hot slug is formed, the robotic arm takes it, puts it into the different extruder size, which are also 3. And then a timer is adjusted to 3 seconds. So the 3 seconds are done, it gets out, and then the extruded part is somewhere to tell us it's done.
Okay.
And then
Is that same line? Same line you guys are going on? So we've got to know when there's a part available. So it rolls down their chute and it becomes available. And so our system now knows there's a workpiece available. I need to pick it up. I need to put it in my tray that can go into the furnace. Right? Once I've got 3 parts in the tray, I tell the automation system that loads the furnace, so the conveyor belt, right? We've got a lot of subcomponents here, right? So we've got the shearing component, and that could be a completely automated process that's modular, and then we can manually do this step if we wanted to, right? So we could modularize our development of this cell. We could implement it in phases. So that's one good thing. So we can sense when we've got enough parts to go in the oven. The time that it's in the oven, that's a time-based process. They've well developed this. They know how long it has to be in the oven to get the parts to the right internal temperature, so the 4G process will work. And I'm sure they've got time deadlines for transferring it from the oven to the forge and all that stuff. So we're not included in documentation yet here. But all right, anybody else thinks that they missed? What is step 4 again?
Basically the same thing minus the oven. We're going to pick and place under the forge, and then forge and then pick and place into it.
Okay, so it's really just a continuation of this. We get it out of the oven, we put it into the forming bags. And then we tell the forge or the press that we're ready to go, and it goes to chunk. Okay, the last 2 steps then. So, ka-chunk, the forge is done. Now what? Well, they actually are supposed to put it in.
Yeah, we do.
Oh, you guys have to unload the forge too? Yeah. Okay. So, all right, ka-chunk. It's in the bin.
Alright. Okay, so, kind of ran through, we're saying it's gonna come in from step 4, at which point we need to align with the die, and the slug needs to be sprayed. It's unloaded into the forge, where,
based off the info we had, there's 15-second one-time fish, maybe more or less, whatever they have. A gripper would then need to pick up the part and spray it again, then place it back in the forge after it's been loaded for a second press.
You're going off the screen, so slide off, am I?
This is not like comfortable.
That totally doesn't work, we don't move the.
Yeah, yeah.
But you can do this.
Watch that.
Watch this. In fact, I've been faced with this scenario many times, and I didn't think of the solution until I was watching you deal with it.
Alright, so then again, the wait time, the forges, the part that needs to be put a suction cup, and the larger end needs to be dipped in water, so not the whole part can't just be lowered into the specific side. Afterwards, it never lets go from the gripper, for the suction cup, and then it gets shifted into the trim press, where there's then the excess trim off, then we added just an inspection step at the end, where,
Because we don't want to make crap,
yeah, so there's
especially when it goes inside jet engines and all our airplanes up.
yeah, so, if it's okay, yeah, it goes to the next benefit, if not, it's corrective action possible, scrap it, specs, all that kind of thing.
Excellent. Can we automate our turbine blade manufacturing process? We certainly can. There is a physical set of steps that allows us to automate. What do you guys think? Should we? Right, it depends. Right. So the question, so if we look at a project like this, a problem like this, the first question we have to answer is can we? Right? Because if we can't figure out the procedure to do it, then there's no sense trying to figure out should we. So we figured out now that yes, this process can be automated. Now, I really hate to believe that anything's impossible. So I'm sure that if we can imagine it, we can, right? I mean, we couldn't go to the moon until we imagined that we could, and then we went to the moon. It didn't take that long. So probably we can. So now the next step is to figure out should we. So how do I decide if I should? Somebody said one of the magic words was cost, right? So how do we use information about cost to then make our decision? Right.
You can compare how much it would cost to have a guy in marketing piece compared to how much it costs to own and operate,
Okay, so let's think about that. So first, we have to understand what's our cost for our existing process. Because we're not designing a process from scratch where we don't have any customers yet. We're replacing an existing process. So the first thing we have to do is we have to understand the cost of our existing process. What goes into the cost of a manual process here? And so this will be similar with pretty much any kind of manual process where you're doing this kind of work. What goes into the cost? What are the factors?
And someone to stand there and load parts.
So labor. What else goes into the cost?
Furnace time and whatever other.
So operating cost of existing equipment. So operation cost. So the cost of doing the work that the customer wants. What else goes into the cost of our existing process?
Materials.
Cost of materials. What else is a cost in our existing process?
The consumables, so the guys wear out.
So consumables. So you may build that into your cost of operation, but yeah, it's certainly a significant cost. Anybody Anybody got a guess about how much a forging die costs to make? For something this size? For something this size?
$5,000.
Between 50 and 100 would be my guess. So if I ran the company that made the die, and you wanted to order one, my price to you would be somewhere between $50 and $100,000. So those dies ain't cheap, and so they can be repaired maybe. So it wears out. You fill it with some welds, you grind it back to the right shape. They can be repaired. Maybe not so much forging dies, but certainly injection molding dies. You know, the injection molding die for a part about this big is about 50 grand. All right, so cost of tooling is a non-trivial cost. What else goes into our cost? What about the salary of the nice person that sits outside the CEO's office and answers the phone? What about your salary? Right, you guys are gonna be engineers, right? You do know that engineers are a cost center at the companies where they work, right? There is an exception. Anybody know the exception? When your company sells engineering consulting, then you're a profit center for the company where you work. But if you sell anything other than engineering consulting, you're a cost center with the company where you work. So we're going to call this overhead. And so we'll put in the overhead things like keeping the lights turned on, keeping the heat turned on, all that kind of stuff. That's all overhead. Paying the rent for the building or paying the mortgage for the building. And so there's actually the cost of the capital equipment too. And so the cost of the capital equipment, we amortize that either over time, so the life of the machine tool, you expect the machine to last 10 years, you divide that cost up by 10 years, and you incur that cost over the 10 years in your accounting system, or you can amortize it over the number of parts, so the useful life of the capital equipment. And so that goes into the cost of making our parts. All right, so now we've got a good idea of what the cost of making our part is. What can we impact with our automation system? Is there anything we missed on cost? I don't think there's anything significant that we missed on the cost. So what can our automation system impact? So we can impact labor. What else can we impact?
Materials. You're better inspecting for that material you're throwing out less.
So yeah, one of our costs in it that we didn't actually write it down is scrap, right? And waste. So scrap and waste are significant materials costs. They may be significant labor costs if we're very far into the process before we scrap the part, right? So scrap and waste, and we can certainly, how do we reduce scrap? So making bad parts. We reduce that by improving our quality, by getting better at making the parts, by having a more consistent process. So we've got a chance of going after this, and maybe we could be more precise with an automated system at identifying where the bad material is, and we can cut it closer. So it's possible that we can do that. All right, so we'll go after scrap and waste. What else can we go after on here in our automation system? Time. We could maybe make it go faster. And time goes into labor, I think, right?
Yeah.
Good, well.
And the overhead.
Do we want to go faster?
You want to at least get to the point where we got
We want to at least get to the point where we're not doing overtime. So we might want to get a bump in time. But do we want to go twice as fast? Not unless we've got something else to use those machines for, right? Because we already know that we've got orders for 20,000 parts a week.
Do you necessarily care about Saturday work for automating the process? Is it more continuous?
Good question.
Do that?
I get the opportunity. I've had it a couple times. I've been able to go to the Pause Automation factory Out at Haas, they've got 1 million square feet under roof. And they run, it's very automated. There's robots at every machine tool pretty much. And they run 3 shifts. And they staff, they say, about 1.5 shifts. So first shift is full staffing. Second shift has something less than half staffing. Third shift basically has a guard and a dog. The guard's job is to feed the dog. The dog's job is to make sure the guard doesn't touch the machines. Right? So you don't necessarily care about Saturday work if you've got it automated such that it runs lights out. So if you do lights out manufacturing, you don't care when it happens. In fact, maybe you want it all to happen second and third shift, so during the day you can use the equipment for something else. All right, so, but yeah, we definitely want to not be making overtime. So we want to get our time down to the level where we can do that. So let's say we figured out, oh, and so what goes into, so we've got, if our new process costs more to operate than our old process, what do we do?
We figure out how long.
Just talking about operation. It costs more to operate the new process than it does the old process.
Figure out.
One, look at if that process can be optimized.
Right, but so we're all done with our analysis. We said, all right, it's going to cost $5,000 per piece to make it with the new process, and we're making them for $4,500 with the old process. What do we do?
Just compare the 2 processes.
Well, we go home, right? If we can't make the new process better than the old process, we're done with the analysis. Because it'll never be cheaper to make it the new way.
But
Yeah.
what if it's like 3 times faster?
Only if we can change our orders by 3 times is there potentially some profit there. So if we can't increase the customer's need by 3 times, then we don't want to make them 3 times faster. But if the customer can buy them at a 3 times faster rate, then there may be another analysis to do. But assuming we're fixed at the number of parts we're making. So first, our new process is going to be cheaper to operate than the old process. If it's not cheaper to operate, it never works. Then we have to consider what's the cost of implementing the new process. So what would the costs include, very quickly? Purchasing all the capital equipment that goes into the new process, right? It'll include the shutdown cost. If we've got to shut down the plant in order to install the new process, there's a cost there. And also the cost of, so we said acquiring the capital equipment, cost of training, and potentially costs of Joe not wanting to lose his job. You could end up with union troubles, right? You could have contract renegotiations. So these are things that we've got to consider in implementing. And so then we say it costs $10 million to implement our new process. And we're saving $2,000 per part as we do that. How do we decide now whether or not we're going to implement the new process? Right, we plot it over time. And we see, so there will be a break-even point, right? Our current process is going at this rate over time. Our new process is going at this rate over time. At some point they cross. You look at how far out in the future do those 2 things cross. And you decide, am I willing to wait 10 months, 10 years, 10 decades in order for this new process to be profitable? And then it's a business decision. You simply decide that it's a judgment call. So I would like to thank you all for your attention. I had fun, I hope you did. And see you on Monday next week, right? We have Monday next week. And we have Monday the following week because it's Tuesday.
We have Tuesday and Thursday. So yeah, Monday's Patriots Day.
Whatever.